So what I want to talk about now is constructive and destructive interference. Well, I've got two wave sources here. We can make them sound, we can make them light, we can make them whatever, but we have two wave sources here. Now, one thing I need to talk about is what these waves are representing. We can express waves in multiple ways. The first way is the traditional wave. We see this in transverse waves, that when we talk about waves, we talk about something that looks like a sine or a cosine wave. Okay? There are other ways of describing that, though. Imagine that I have several waves moving along like that. So they're identical both in, shape and in you can say then is I have what's called a wave front. So see, all my peaks are all lining up, so I can express that as a wave front. So I can simply draw my waves to look like that. Okay? Cool? So the first way in which we do it, we draw it like this, where we can see the wavelength, the amplitude, all of that information. Or we can express them as wave fronts, where between here and here is a wavelength. Okay? But that's the only information that's carried on that. The other way in which we can express a wave is called ray diagrams, when we don't concern ourselves with the information of the wave, the amplitude, the period, that sort of stuff, but only concern ourselves in the direction in which the wave is traveling. Okay? So we can draw an arrow where the arrow intersects the wave fronts at right angles. Okay? And we call this a ray. Cool? Now, if we have a circular pattern, which we certainly do for most situations, all we have to do is draw a ray like this, and right where it intersects that circle is my ray, or is my right angle. So for something that looks circular, we just have something that looks like this. Okay? And then we have this, which we call a plane wave. So we've got circular waves, we have plane waves, and how we're drawing that is, first of all, we can draw it like this, which is kind of confusing, and we're keeping track of a lot of information, or we can draw it using wave or an array diagram. Okay? So these are all ways in which we can express what a wave looks like. Now, so what I have here is I have a drawing of a wave. Let me erase this. I have a drawing of a series of waves that are creating a wave front. Okay? So here's my wave front. Two sources. I have a source here and I have a source here. And the white one is creating the white wave fronts, and the pink one is creating the pink wave fronts. Okay? And you can see there are points where those wave fronts are interacting with each other. As a matter of fact, those waves are interacting with each other all the way. Just trying to dry off the board a little. So what we have here at the wave fronts is we have the peaks. So here's a representation of all the peaks, and here's a representation of all the peaks. So using my white wavefront, at this point right here, I have a wave that looks something like this. So I have a peak there. And at the other wavefront here, I have another peak. So I have an interaction between these two peaks. Okay? Now think of this as forces. If I have a push up and a push up, I have a really big push up. So the sum of those waves is like that. It's twice the amplitude. It's the amplitude of one plus the amplitude of pink. So the total amplitude there is twice the original amplitude, or twice the total amplitude here is this amplitude plus this amplitude. Okay? And that's what's referred to as constructive interference. Okay, so the principle that allows me to add these amplitudes together is called superposition. So it allows me to add the property of this to the property of that to get this final property. It's just a law of superposition. I don't know why they call it super, but it's what it is. And when these peaks are lining up, I'm getting constructive interference. Now, if it was a trough lining up with a trough, we would still call that constructive interference. I'm doubling my amplitude. It just so happens that's a negative value. Negative amplitude gives me twice the original amplitude, but it's negative. But it's still constructive interference. Okay? So that's constructive interference. So these points right here and here and here and here and here and here and here to us. I'm going to talk about destructive interference in the next video.